Welcome back to the Deep Dive. Today, we are immersing ourselves in the fascinating world of a plant whose very name, Salvia Divinorum,
Hmm.
it hints at something profoundly mysterious, maybe even supernatural.
Yeah, it's got these nicknames too, right? Magic Mint, Divine Sage, sometimes just Sally D.
Exactly, and it looks, kind of like a humble herb from the mint family, but it carries this truly colossal reputation.
Oh, absolutely. And that reputation is definitely earned. I mean, this unassuming little shrub contains salvinorin A.
And that's the kicker, isn't it?
It is. It's recognized as the most potent, naturally occurring hallucinogen known to humankind, period.
The effects are just intense. Potency is massive, and critically, the biology behind it is, well, frankly bizarre.
It really is.
So our mission today is to kind of move beyond just the trip reports and really understand the science. We need to decode how this rare plant evolved into such a chemical powerhouse and, why its main ingredient works totally differently from all the other classic psychedelics we've studied.
Exactly.
Right.
We're going to drill into the biological rarity, the history, and especially that unique pharmacology that just sets Salvia Divinorum completely apart.
You might have heard the stories, but we promise you the actual chemistry here is far stranger and maybe more compelling than the experiences people talk about.
Definitely stranger.
Okay, so let's start at the roots, literally. We're talking about Salvia Divinorum, and it's in the Lamiaceae family. That's the mint family.
Right. And visually, yeah, it grows like a small shrub, maybe up to 5 feet tall. It has those characteristic square, hollow stems you see in mints.
So it's pretty ordinary, almost common.
It does, doesn't it?
Yep.
But its growth habit sort of reveals its extreme fragility. Its stems, they're prone to falling over, trailing along the ground.
Okay.
And this trailing nature is actually critical because wherever the plant nodes touch the soil, they can root. That allows the plant to spread vegetatively.
Right, so it doesn't rely on seeds as much. Why is that vegetative spread so important to its whole story?
Because S. divinorum is, well, it's a botanical rarity. It only flowers sporadically, usually during the rainy season, maybe May to September.
And even then,
Those flowers rarely, if ever, produce viable seeds. So in the wild, it essentially struggles to reproduce sexually. Like, really struggles.
wow. So reproduction through traditional seeds is basically off the table or close to it.
It's severely limited, yeah. Which means its entire survival strategy relies pretty much exclusively on cuttings, or those trailing stems that root themselves.
Okay, so that leads to...
It leads to this really stunning biological fact. Most salvia plants that are cultivated worldwide today, they might actually be genetic clones.
clones.
Yeah, clones of just a few original specimens that were collected maybe centuries ago.
Wow. An international clone army of psychoactive mint, all stemming from just a handful of ancient individuals. That's an evolutionary fluke if I've ever heard one.
It really is something.
Okay, for you listening, we need to pause and clarify something important here because the salvia genus itself is huge.
Oh, absolutely critical distinction. When we say salvia, most people immediately think of, common kitchen herbs.
Right, like the stuff you put on chicken.
Exactly. This plant is not Salvia officinalis, which is your common culinary sage. And it's also not rosemary, which, fun fact, was actually reclassified into the Salvia genus back in 2017.
Huh? I didn't know that about rosemary.
Yeah, it's Salvia rosemarinus now. But the point is, those are just harmless flavor agents. They contain absolutely none of the psychoactive components we're talking about here.
Got it. And this incredible chemical potency we were talking about,
Yeah.
it's confined to an incredibly tiny geographical area, isn't it?
It is. That rarity factor gets compounded by a really specific geographic constraint. S. divinorum is endemic, meaning it's exclusively native to a very small area within the Sierra Mazatec region.
Where's that?
In Oaxaca, Mexico.
Yeah.
It thrives in these humid, high-altitude places like cloud forests, tropical evergreen forests, usually near stream banks.
So a very limited, very specific home range that definitely adds to the mystique.
It's huge.
Okay, so moving from the biology to the history. We know the indigenous Mazatec people in that exact region have interacted with this plant for potentially hundreds, maybe even thousands of years.
That's right. And the Mazatecs still use salvia today, primarily for spiritual healing, medicine, and most famously for divination.
Divination, that practice of seeking knowledge,
Yeah.
maybe about the future, from supernatural means.
Exactly. And that concept, divination, it's so central they actually put it right there in the scientific name, Divinorum.
Makes sense.
And the traditional way they consumed it gives us our first clue about the unique chemistry involved. Traditionally, the Mazatec would chew these large wads of fresh leaves.
To chew them.
Yeah, or sometimes ingest concentrated preparations like teas or tonics made from it.
Why chewing, though? If the goal is potency, wouldn't you just, I don't know, swallow a pill or drink a really strong brew?
But if you just swallow it, the active substance, salvinorin A, gets broken down way too quickly by stomach acids and then liver enzymes. It doesn't really get a chance to work. But by chewing the fresh leaves and kind of holding the juices in the mouth.
The sublingual route, under the tongue.
Precisely. The mucous membranes in the mouth provide the quickest, most effective way for that psychoactive substance to get directly into the bloodstream and up to the brain without getting metabolized first.
A very targeted delivery system.
Yeah.
Developed over centuries, presumably through trial and error.
Reflects deep practical knowledge, absolutely.
Okay, now contrast that traditional, slow, maybe more ritualized method with the modern approach, which often involves smoking concentrated extracts or just the dried leaf.
And smoking is really what gives salvia its reputation for sheer speed and intensity. When it's inhaled, the effects are almost instantaneous, sometimes, under a minute.
That fast.
That fast. It's so powerful that users often describe the experience as significantly more intense, more disassociating than classic psychedelics like LSD.
Wow. More intense, yes, but also incredibly short-lived,
Yeah.
right? Which is maybe its saving grace.
That's the key trade-off. That intense experience departs almost as quickly as it arrives. It returns the user to baseline in about, say, 30 minutes, maybe an hour tops.
So it's like a quick, powerful flash compared to the hours-long journey you get with other psychedelics.
Exactly. A very different kind of experience profile.
Okay, this brings us to the real core mystery of this plant, the unique chemical identity of salvinorin A.
Right. This substance, so powerful it causes intense hallucinations, this feeling of complete disconnection from reality.
And what's incredible is, despite its ancient use, this chemical wasn't even isolated and identified until the 1990s.
Isn't that amazing? A modern scientific discovery, really, built on ancient wisdom.
But here's the major chemical anomaly we really need to get our heads around. Salvinorin A is an outlier. It's a complete outsider in the world of psychoactive substances.
For two main reasons, yeah.
First, it is not an alkaloid.
And this is a massive distinction. I mean, think about the major classic hallucinogens, psilocybin from mushrooms, LSD, mescaline from peyote, DMT. What do they all have in common chemically?
They're all alkaloids.
They're all alkaloids, meaning they're naturally occurring plant compounds that contain nitrogen atoms. Nitrogen is like the chemical cornerstone for almost every famous psychoactive drug we know.
Right, because that nitrogen allows them to mimic our own neurotransmitters.
Precisely. That nitrogen atom structure lets those substances mimic neurotransmitters, which are often nitrogen-based themselves, things like serotonin or dopamine. But salvinorin A,
No nitrogen.
zero nitrogen, it's a deuterpenoid, composed solely of carbon, hydrogen, and oxygen. Structurally, it's completely unique among natural psychedelics.
So, okay, we have a hallucinogen that looks nothing like its peers on a molecular level. And if it doesn't have that alkaloid structure, well, it follows that it doesn't interact with the brain in the same way either, right?
And that is the second, and arguably the most important part of the anomaly. Classic hallucinogens, LSD, shrooms, mescaline, they're what we call serotonergic psychedelics.
Meaning they work on the serotonin system.
Right. They mimic serotonin. They bind powerfully to specific serotonin receptors, the 5-HT2A receptors mainly. And that disrupts perception, thought, mood.
That's kind of the default setting for the psychedelic experience we usually talk about.
It is. But salvinorin A completely bypasses the serotonin system. It doesn't touch those receptors that LSD or psilocybin rely on. Instead, it interacts primarily with the brain's opioid receptors.
Okay, hold on. That is where it gets truly jaw-dropping. We're talking about the same class of receptors that are unfortunately hijacked by powerful, highly addictive drugs like morphine, heroin, fentanyl.
The very same system. And this is crucial, salvinorin A isn't used like those drugs, and it certainly doesn't feel like them.
Why not? What's the difference?
Well, that difference in experience comes down to the specificity of its action. See, the opioid receptor system is complex. It has several different subtypes, different flavors, if you will.
Right.
Highly addictive drugs like heroin, they primarily hit the mu-opioid receptor, the MOR. That's the one strongly associated with pleasure, euphoria, pain relief, but also physical dependence.
The reward receptor.
Essentially, yes. Salvinorin A, however, is an extremely potent and selective agonist, meaning it activates a different one, the kappa opioid receptor, or KOR.
KOR. Okay, that's a name that doesn't usually come up in everyday drug discussions unless you're deep into research. What does activating KR actually do?
Well, while the mu receptor is often about reward and euphoria, the kappa receptor is frequently linked to the opposite effects, things like stress, pain perception, and importantly, a profound sense of dissociation or dysphoria.
Dysphoria, that feeling of being unwell, dissatisfied, uncomfortable.
Exactly, aversive feelings, basically. This connection to the KOR helps explain the really strange nature of the salvia trip.
Ah, okay, so that sudden, often bizarre and uncomfortable feeling of detachment or being in multiple places at once, like that famous anecdote about seeing an intergalactic school bus driven by a teddy bear.
Yeah.
That's a dissociation caused by hitting the KOR.
Precisely. Activating the KOR can fundamentally interrupt the brain's ability to integrate sensory information properly. It leads to those really bizarre, intense perceptual distortions. It quite literally can disconnect you from your immediate physical reality.
Wow.
And this unique, very specific activation profile is what makes the plant so rare biologically and also so incredibly valuable scientifically.
Which brings us neatly to the great paradox here. We've established this plant contains the most potent natural hallucinogen known, and we know it works on the same system that underpins some of the worst addiction crises globally.
Right.
So this raises a massive question, one that really demands a deep dive. How can a compound that potent hitting the opioid pathway not be wildly addictive? It just seems completely counterintuitive.
It really is the ultimate contradiction, isn't it? And the answer seems to lie in that KOR specificity we just talked about. Studies looking at users show that outside of maybe a traditional ritual context, salvia is generally not a popular substance for recreational abuse. People typically use it only once or very rarely, often just out of pure curiosity.
Because, let's be honest, it's often not particularly pleasant.
Exactly. Those dysphoric effects from KOR activation, they're generally not rewarding in the way addictive drugs are. People typically don't crave an intense, quick trip that leaves them feeling detached, maybe confused, and often kind of strange.
Makes sense.
Yeah, researchers found that almost no users reported experiencing a craving for salvia after using it. And craving is the absolute hallmark of addiction and dependence. So it's potent, yes, but not rewarding in the specific way an addictive substance needs to be.
Okay, so that non-addictive nature, combined with its highly specific interaction with the kappa opioid receptor, that's pivoted research away from just, wow, this is weird, towards a huge therapeutic promise.
Right.
Absolutely huge, because salvinorin A is a KO agonist, not an MOR agonist, and critically, because it doesn't seem to cause craving. It's being intensively studied now as a potential treatment for drug addiction.
Particularly opioid addiction.
Especially opioid addiction, yeah. The core idea is that modulating the KR system, maybe activating it in specific ways, could potentially help dampen down the addictive reward pathway associated with the MR system, like counterbalancing it somehow.
That's a powerful potential connection. The plant that gives you arguably the most intense natural dissociation might also hold a key to treating the world's most severe addictions.
It's a fascinating prospect. One study didn't really mince words. They called salvinorin a compound of high therapeutic promise in the treatment of drug abuse.
High praise.
And that potential might even extend beyond addiction. KR antagonists, so compounds that block the KR, are also being studied for their potential in treating things like mood disorders, depression, anxiety. Given the KR's apparent role in the stress response and those dysphoric feelings, so salvia, or salvinorin A specifically, provides this kind of chemical blueprint for targeting this unique system in the brain.
A whole new toolkit.
Basically. And since salvinorin A is, relatively speaking, a newcomer to mainstream science, there's still a lot to learn about its full range of effects, both rewards and possible risks. But its unique chemistry has definitely opened a brand new door for psychopharmacology research.
Okay, let's try and unpack this and bring it back home for you listening. We started with this plant, a rare cloning mint, endemic to just a tiny corner of Mexico.
Right, traditionally used for spiritual divination.
That somehow evolved to produce the most potent natural hallucinogen we know of.
But the biggest takeaway, I think, the real nugget of knowledge here, is the science. This is a powerful hallucinogen that completely bypasses the usual serotonin system of classic psychedelics.
Skips it entirely.
And instead, it interacts with the opioid system, but specifically that non-rewarding kappa opioid receptor.
Which is key.
Absolutely key. And this unique chemical blueprint, it offers us a fundamentally new way of maybe understanding the mechanisms of consciousness itself, and perhaps more urgently, provides a potentially novel avenue for treating addiction.
So we have this ancient use for seeking, let's call it divine insight, and now modern research focused squarely on medical application. We've got the divine vision on one hand and the medical promise on the other.
A real duality.
Which aspect of this really mysterious plant's future do you think will ultimately define it? Will it be the spiritual power recognized by the Mazatec for centuries, or the cutting-edge pharmaceutical promise held within its unique chemistry?
That's the question, isn't it?
Definitely something to mull over until our next deep dive.